Hello, I'm Kayser, network engineer at LINX. My presentation is about our recent LON2 refresh. We moved from EdgeCore and OGNOS to Nokia IXR with LINX. I'll give you a quick overview about the lead up to the refresh, why we'll still maintain 2 LANs in London, and also touch on how we did the migration. LINX operates 2 separate exchange fabrics in London, LON1 and LON2. They're based on different hardware and different NOS stacks, but they are available at the same POPs in London. This reduces single point of failures, provides vendor diversity, and limits the blast radius in case we have any software issues. Members can connect to one or both. That's a resilience versus cost trade-off. Quick history of LON2. LON2 was established in 2002 mainly as a response to member requests for a redundant solution in London. Around 2015, we knew that the Extreme platform wouldn't scale or automate the way we needed, so we started looking at replacements. One of the solutions we investigated was a disaggregated model based on white box switches and third-party NOS. In 2018, we then introduced the EdgeCore switches with OGNOS from IP Infusion, together with a new EVPN VXLAN spine leaf architecture. And finally this year, we introduced the Nokia IXR switches in LON2 to cope with increasing port speed demands. Why did we refresh LON2 in 2026? There are 3 reasons for that. Our existing switch and NOS support approached end of life, and we required an economic way to provision 400 gig ports and beyond, which proved to be difficult on our existing platform. Finally, we wanted to future-proof LON2 using a more mature and proven platform. In the end, we went with the Nokia IXR series and LINX, which we were already using in some of our regional exchanges. In addition to the IXR D2 and D3, which we use for 10 gig and 100 gig in our regional exchanges, we also deployed the IXR D5 for 400 gig in the core and on our edges for the first time. The network design stayed unchanged. We continue to use VXLAN EVPN deployed on merchant silicon infrastructure, but we moved away from white box switches as they could not realize any additional benefit in our environment. Operationally and automation-wise, we now benefit from a more mature and completely model-driven NOS and gained GNMI for telemetry. Members can now connect to ports from 10 to 400 gig, 800 gig and more are already in the hardware roadmap. The migration was done in 4 steps. We started in November building a new fabric in parallel to the legacy fabric until December 25. And then in December 25, we turned up the NNI between the legacy EdgeCore and the new Nokia IXR fabric. From December 25 to January 26, over the Christmas change freeze, we had a soak period where we did stability testing, i.e. reachability tests within the new fabric and between the new and old fabric. In February 2026, we completed the migration over 6 maintenances side by side. And how did we do the actual migrations? We started with a small pilot site at Telehouse North 2 and finished with our biggest site in Telehouse North with over 140 members. On site, we had engineers doing the physical work, and remotely, engineers were focusing on doing config deploys and verification work. All deploys were done using our in-house automation system, which was pre-configured for the port moves. Members were removed from the old fabric, then provisioned on the new fabric. And since everything was pre-configured in our automation system, that part went quite smoothly. Post-migration, we then did automated verification tasks to identify residual issues. To streamline each maintenance, we tried to automate as much as possible of the validation steps. focusing on issues with a high likelihood and time-consuming validation steps. First, before every maintenance, a pre-migration audit was conducted, providing the reference values, which the automated checks then compared with the post-migration values. We had several types of automated tests, layer 2 and layer 1 and 2 port state test, highlighting ports whose state has changed significantly. And if that failed, our on-site staff would immediately validate the physical connection. Then we had tests to confirm a certain MAC table issue we had with the previous platform, where the software and hardware MAC table could get out of sync. And this hit us in the past when we did port migrations. So we tested for this issue automatically. And if we found such an issue, we immediately deployed workarounds for this bug. And finally, we had tests for root server session status and ping tests checking reachability between key nodes in old and new fabric and the migrated ports. Those last ones, they served as a catch-all for all the remaining issues. One identified issue was, for example, that we had set the limit for learned MAC addresses too low on our NNI ports, so we had to raise that during the migration. And I want to conclude this presentation with a summary why LON2 is still relevant. Joining both LON2 and LON1 provides you with redundant root server clusters, ports and paths in the London metro area. But if you just join LON2, you're still getting a full-featured peering LAN with hundreds of peers. Looking at the future, the LON2 platform is ready for 800 gig ports and SR LINX stability, and the feature set allows us to extend the platform further into the future. LON2 is in a side project. We have more than 300 members connected to LON2, which is about a third of all the LINX members. Traffic peaks are approaching already a terabit on LON2, and there was a 7% connected capacity growth in 2025. Finally, all the LON1 services, peering, private VLANs, closed user groups, portal stats, etc., they're all available on LON2. Thank you for listening.
Thank you, Jan.
Thank you.
Any questions for Jan? I'd like to ask if people are asking questions, then they're still coming, Jan. Come back. Jan?
Yeah. Oh, people are asking questions.
Please state your name and affiliation before you make your question.
Yes.
Over to you.
Hello. Hello, is it on? Hello. Tom Bird of Portfast and formerly IX Leads. So have you given up on white box hardware now? Yeah.
Why we did not pursue white box hardware with the refresh? We originally thought that might be a good idea to have the option of deploying different NOS on top of white box hardware, but we found out that the NOS are actually quite dependent on the hardware, and it would not have been easy to midlife cycle of a switch to change the NOS to another one. So that did not turn out to be a very feasible option for us.
Okay, thank you.
Yeah.
Good morning, David Steculorum from Cloudflare. I had kind of the same question, so I'll use my backup question. You mentioned building in parallel for this new platform. What was the impact on your footprint in a data center, and did you have to do more synchronization with the co-location facility for the migration?
Sorry, can you reword the question?
Yeah, so in terms of footprint, right, of having to have basically two networks, right, at the same time, the old platform and the new platform, what was the impact in terms of footprint in the colocation facilities?
Okay, so we had already spare racks in all our facilities, so that did not pose an issue. We just installed the new fabric in a new rack in parallel to the old one.
Okay, and so to move those connections, right? Because I suspect there's hundreds of connection. Did you have to use colocation crew to move from one rack to another? Or?
We used our own staff, and it was basically just moving connections from one rack to the neighbor rack, so that did not cause much of an issue.
Excellent. Thank you very much. Thank you, Jan.
Thank you.